Hi, thanks for taking some time to sit down and watch this video on self-healing applications. I'm Tim Carr. I'm a cloud automation orchestration specialist with a head. And in this video, we're going to talk through how we're going to take an application and scale that application out so that it can serve more workload. We're going to leverage three tools to do that. We're going to leverage Cisco AppDynamics, which is going to provide us a capability of monitoring the application itself for the number of transactions that are happening. We're going to leverage Cisco UCS-Director to actually orchestrate the addition of a new node to our application environment. And we're going to tie that all together with ServiceNow so that we can put the appropriate ITSM tooling around that process. So change tickets and ultimately service mapping, so on and so forth. So let's jump right in. As we kind of get familiar with what we're going to do today, we really need to understand what our application actually looks like. So our application is pretty simple. Our application provides an API service, and that API service happens to be for bag tracking data. At Ahead, we've created a fictitious company called Ahead Aviation, and we happen to write an application for this fictitious airline that allows us to track bags. We did that because we felt it was a good example of an actual app that would be out there today. This application happens to take advantage of an Nginx front end and happens to take advantage of application servers running behind that Nginx front end, and then call back to a MongoDB cluster. For the purposes of our scaling activity today, we're going to scale out the application servers. So we're going to develop an orchestration that actually stamps out a new application server and adds it to the cluster. But to do that, we need to understand when it's appropriate to do that. So let's talk about that whole process and what goes into making that happen. So to make that process happen, we need three components. We need a monitoring component that allows us to set some thresholds for when we might want to trigger an orchestration. And here we're going to leverage AppDynamics as that monitoring component. AppDynamics is an application performance monitoring tool that leverages agents to understand communications between distributed application components. For example, AppDynamics can tell us how long a query would take from an application server to a database server to come back. It might know that that query takes 300 milliseconds, so on and so forth. And it'll let us set a good threshold for what acceptable performance might be versus unacceptable performance. So in the case of the 300 milliseconds example, an user might be sitting there looking at their application saying, why is this taking so long? So perhaps we need to set a threshold at like 50 or 60 milliseconds, something along that line, so that we get acceptable user performance. AppDynamics allows us to first identify how long that takes, and second, set an appropriate threshold. When that threshold is breached, AppDynamics allows us to trigger a reaction. And we're going to show that today, and we're going to talk about that. In the middle, you'll see ServiceNow here. What we're realistically going to do is we're going to trigger an event from AppDynamics that calls to ServiceNow. Now, you might be wondering why we don't just go right from AppDynamics to an orchestration engine to actually give us that additional server right away. Well, in this case, what we really want to do is we really want to be able to open up an event in ServiceNow so that we have the appropriate change management process for our application, because it's a fictitious company and a fictitious enterprise company, we want to treat this application as it would be under change control. And even though we're orchestrating and automating, and no humans actually touching the keyboard to make these changes happen, it's important that we still audit and create the appropriate change records for when the orchestration tooling creates those changes. So we're going to call out to ServiceNow first to create an event and to ultimately then trigger a workflow within UCS-Director that grabs a new VM, ultimately calls out to Puppet and allows Puppet to do the application configuration and then updates our whole application stack. So that's the workflow that we're going to implement. I'm going to get into demoing that whole process for you right now. That's enough of slides. Let's get to the demo. Okay, I've logged us into ServiceNow to kind of give us a quick little overview of what this process looks like. Once again, our bag app is an API front end that's served up by a couple of app servers that you can see here. Here's App Server 160 and App Server 150. They talk back to a Mongo database cluster that's right here. The front end of this app server is proxied by Nginx, as discussed. And so really it looks pretty simple. And I've really zoomed in within the ServiceNow dependency mapping to only show the components of the application itself. If we were to just take 1 second and zoom out, you would also see that we have dependencies on our physical infrastructure, including our networking and VMware ESX environment. So that's kind of portrayed here. I've gone ahead and created load on our BAG API application front end. And you can see the load that I've created here within AppDynamics is starting to show that we have some pretty good calls per minute happening within our application. So, as discussed earlier, this is the AppDynamics interface, and what we're actually able to see is we're able to see the business transaction, how many calls per minute are actually happening in our environment, and what the average response time for all those calls are. You can see that we're at a pretty flat 50 milliseconds-ish for these calls, so AppDynamics has gone ahead and kind of built some understanding around that being a pretty good baseline for our application. Now, there's multiple ways for us to leverage AppDynamics to create thresholds. We can create thresholds based on business processes. We can create thresholds based on virtual machine characteristics, meaning your traditional CPU, memory, load, that sort of thing. Or what's more interesting to me is you can leverage AppDynamics to take a look at response time or load in terms of calls per minute. For me, that makes AppDynamics just a little bit more valuable for what we can do than the average dumb, my CPU is at 60%, it's time to scale out sort of thing. If I've architected my app to be able to respond to X number of calls per minute, I can be a little more granular with how I'm architecting my scaling. So what you'll ultimately see here is you'll ultimately see that our application becomes a little bit, becomes just a little bit more and more flaky. We've built this application to understand that it kind of has a threshold at about I believe it's like 5,000 calls per minute or so with the way it's scaled. And what we've actually done with that is we've designed in the back end for when it surpasses that, we trigger a workload capability where we call back to ServiceNow and start the process of scaling out. So that's what we're actually going to show right now. So we're going to need to jump over into ServiceNow to actually kind of walk through this. We've got a couple of different things that happen, right? AppDynamics sees that there's an issue, and it actually calls back to ServiceNow to say, hey, I have a problem in my environment. ServiceNow then calls out to UCS-Director to kick off a workflow. This is actually the workflow that UCS-Director kicks off. You can see that it's provisioning a new VM, and really what it's doing is it's running through our VMware vSphere environment and saying, okay, do I have enough to allocate this capacity? Yes. And okay, I'm going to spin up a VM. I'm going to add a DNS record. And the real cool part is then we install the Puppet agent, we classify the VM within Puppet, and then we tell Puppet that, hey, we need you to go out there and install all the prerequisites for our application server within the BAG app API application. So we do all of that process every time we add a new node, and this is the workflow that we're kicking off. I just wanted to give you some insight there. Our app should have already exceeded its boundaries, and so we should, if we jump over to look at the service request in UCS-Director, we should already see the process of those VMs being spun up within UCS-Director. So let's have a look here. Yeah, you can see right now that we have service request 181 and 182 in progress, a couple new VMs to be able to serve that extra workload. And as those come online, we are actually going to be able to jump into ServiceNow and see that request be completed. Let's just give it a second here on the refresh button to finish that process. These VMs are spinning up in the back end in our systems right now. I will pause the video here while that happens. just wanted to look in on those requests again. We can kind of view some details as to how these are coming along and look at the time and so on and so forth. You can see that we've initiated the request at 23:51, and it's about 4 or 5 minutes later now. We have gone ahead and provisioned the VM. Took about 40 minutes, and oh, there you go. We can see that we classified the VM, we kicked off the Puppet run, and now the request is complete. So all in all, you can tell that it took us, about 5 minutes or so to get everything up and running for a new VM to be online and added to our application. So now let's jump back to ServiceNow and look to see how everything happened in ServiceNow. So if we go and take a look at our Bag App CMDB here, we have all the information about the Bag App that we're running, and I have that dependency view up. You'll notice now that when we look at the Bag App, we're actually going to have a few extra machines in here, and that's where this starts to get cool. So let's have a look at the dependency view again. You'll notice that when we fire up the dependency view, now instead of having the app server 160 and 150, we actually have a couple of new app servers here. Those are the ones that were just spun up. Not only do we have a couple of new app servers, but the really nifty part about what we can show within ServiceNow is actually the change request and how these are related to one another. So if we look at the details of what happened within this environment, you can see that there was a change request that actually happened, and it happened this evening. That's exactly what we just kicked off. And when we look to see a little bit more about that change request, we can see that, yeah, our cloud machine standard change actually kicked off and happened. What happened actually was a low impact change, and we added a CI, and that is app-sr182, and that's really interesting because if we go back into UCS-Director, we can see that the service request that we did was the service request 182. So everything lines up from an auditability perspective. So not only do we have the history here within UCS-Director, but we've also collected some really great history within ServiceNow as well. So if our IT organization wants to come back from an audit perspective and say, hey, what happened in my application at this hour, we have a change ticket for all of the stuff that we've automated. So it's covered when we want to scale our application through automation. So ITSM tooling still works in that arena. I think the other great part about what we have here with ServiceNow is we have this great dependency mapping, and we've talked about this a couple of times. I think the reason why dependency mapping is actually really important as you start to get more and more automated and start to use other platforms is that you actually get to see how components relate with one another within a dependency mapping. Here we actually have something kind of interesting happening as well. And I don't know if you can actually see it, so I'm going to make it just a little bit bigger so that everybody can see it. These are all of our virtual machines that are running in our application stack. And I want to know if you can spot something that's actually wrong with this picture. In this case, things aren't quite evenly distributed. While we do have some capabilities in our environment for apps to be running where they should be, right, like evenly distributed, you'll notice that 3 of these app servers are running on one ESX host while one of them is running on this other server. So that's just something that you're able to pick up by having dependency views. This dependency view would also be able to pick up, for example, if all of these machines were on one and you had a problem, and in that case, we could actually say, hey, alert us if that happens, right? So there's quite big advantages to leveraging this, and that goes beyond just leveraging this in a on-prem arena. This sort of thing can also be leveraged in a cloud environment. We could substitute ESX servers for availability zones and mapping, for example, EC2 instances to availability zones so that we can show that our apps are resilient. Having this visual dependency map's actually a really nice way to know how your application all fits together. And this is a great logical view of how the whole Bag app plays with one another in our environment. So we've shown the change, we've shown the dependency view, we've shown Cisco UCS-Director going out and doing its job by deploying our new VMs, and we've shown that all triggered by an event from AppDynamics because we had an event, and you could actually see some of the response times fall off and some of the workloads fall off in our environment as well. It looks like our load generator was done, and that's great. You can see that our business transaction health is back to normal. Node health is not. It's because we removed a few nodes a little bit earlier, but beyond that, everything is up and functional with multiple nodes in our environment. So this is pretty much how you pull all three components together to create a self-healing application. We use AppDynamics to provide that baseline, to provide that trigger. We use Cisco UCS-Director to provide the orchestration, and we use ServiceNow to provide the ITSM tooling for change ticketing and the dependency views in our environment, and to map all the components together. I'd like to take a chance to invite you to our offices if this kind of resonates with you. We have a lot of different examples of how we're doing this for on-prem workloads, for public cloud workloads, and other self-healing type operations that we've done for other customers. So when you get a chance, reach out, and we're happy to have you in for a briefing. We're happy to have you in to show you the lab and show you what we've been up to. In the meantime, stay in touch, and feel free to reach out to Ahead for your needs here as it relates to understanding this technology just a little bit better. I thank you for your time.